So we have learned how to solve quadratic equations, right? What methods have we used to solve quadratic equations? Factoring, yes. And the quadratic formula, right, okay. So today we're going to look at some other ways to solve quadratic equations. For instance, let's say that we had x squared equals 25. How do I know that that is a quadratic equation? Yeah, because of the x squared. Because normally when we think of quadratic equations, we're thinking the standard form, ax squared plus bx plus c. But we don't have that. But we know it's quadratic because the x is squared. These are actually really easy to solve because you can probably solve that in your head already, can't you?
Yeah.
What does x equal? 5. Because what?
Squared.
5 squared is 25, right? So in your head, you're like, okay, I know x is 5. But actually what we're doing, right, because we want to end up with x equals something. So what we're doing is we're taking the square root of both sides of this equation. And if I take the square root of x squared, what are we left with? X. And the square root of 25 is? 5. But it's actually plus or minus 5. Because negative 5 times negative 5 is also equal to 25.
Right.
So x is actually 5 or negative 5. Okay. How about this one? X squared equals 64. In order to solve this, we're going to take the square root of both sides. So that gives me x equals almost plus or minus 8. Yes, plus or minus 8. Okay. How about this one? X squared equals 8. Good, yeah. So we can take the square root of both sides. So we get x equals plus or minus the square root of 8, which we're going to simplify. 2 times 4. Right. So remember, I've got 2 of a kind, so those 2's come out. So it's plus or minus 2 square root of 2. And we leave our answer just like that. We do not put it into decimal form. Okay. How about this one? X squared plus 8 equals 96. So here, I want to take the square root of both sides, but I can't.
Subtract 8.
Right. So I've got to get it so that it's just x squared equals one number. Okay. I get x squared equals one number. Now I can take the square root of both sides. So we get x equals plus or minus the square root of 92. Oh, I don't know why I got 92. That's a good question. Where in the world did I get 92? That's funny. Just wanted to see if you were paying attention. 88.
Yeah.
Okay. So now let's go ahead and factor that 88 down. We've got, Yeah, 8 and 11, and 8 is 4 times 2. Okay, so I'm going to rewrite this plus or minus. Square root of 4 times 2 times 11. And then we know the square root of 4.
2.
So it's plus or minus 2 square root of 22. Okay. See how important those radicals were? We spent a lot of time. I made the final exam this weekend, and I was shocked at how much time we spent on radicals. But that's okay, because you see, we really need to know how to simplify radicals. We had them in the quadratic formula, and now we've got them again here. Okay, so we had to get a nice, strong foundation on radicals.
Is the final going to go all the way back from the beginning?
No, just January.
Bless you, sir. Thank you.
Okay, let's look at this one. How about negative 2x squared equals negative 196. What should we do?
You just
Right, I can't square with the negative.
-2.
Yeah, but let's divide by negative 2 first. And then when I divide a negative by a negative, I get a positive. Yes. X squared equals positive, what is that, 98? Yeah, positive 98. Okay, then what do we do?
X equals plus or minus the square root of 90.
Good. So x equals plus or minus the square root of 98. And 98 is 2 times 49. And that's nice. 7 root 2. Good. So the one thing that we're actually I'm not going to test you on or anything, but just so that you know what we're doing when we're solving these quadratic equations, all the stuff that we did on that last test and all. So a quadratic equation, like, we know that it has a shape like that, right? And we know how to find the axis of symmetry. We know how to find the vertex. We know how to find where it crosses the y-axis. When we solve it, we're finding where it crosses the x-axis. Okay, and that's another very important part of the parabola. For instance, remember when we first learned parabolas, I gave you examples that involved things like kicking a football, things like that, right? So you had this, what we called a parabolic path, right? So you had this shape that did this, right? There's my vertex. Well, if this is a football I'm kicking, what does the x-axis actually represent in the real scenario? Or, yeah, how far it travels or where it hits the ground, right? So knowing that x-intercept, knowing where it crosses the x-axis is very important, because that's telling me where it hits the ground or how far it travels, okay? And that's what we're doing when we're solving these quadratic equations, okay? We're finding where it crosses the x-axis, okay? I'm just trying to keep it a little more manageable for you, and I'm not going to ask you to graph it with the x-intercepts. I'm just asking you to solve it, okay? But at least you know what solving it is doing. All right, 6x squared plus 10 equals 394. See if you can do that one yourself.
2, please. Appreciate that. Oh, man. Try to go.
Anya, is this your phone? No. Oh, so it's right up there. Right up there. Aya, do I have your phone? No, it's not bad.
Okay, so what do you think our first step is?
Divided by
Subtract 10. Yes, good job. We're going to subtract 10. So we get 6x squared equals 384. And then divide by 6. So x squared equals 64. And then square root both sides. So x equals plus or minus 8.
Oh, well, yeah.
By the way, I would get the same answer if I used the quadratic formula. Okay. But it's going to take a lot longer. So if I use the quadratic formula, what would I do first? What does it have to equal when we use the quadratic formula? 0. So I would subtract 394. All right. So then we have A equals 6. What does B equal? 0. And C equals negative 384. So we'd have x equals negative b, so that's 0, plus or minus the square root of b squared, so it's 0, minus 4 times a times c, all over 2a. So we get some big numbers. I need a stool on wheels. Wheels on here. Okay, so we get 4 times 6 times 384, square root 9216 divided by 12. And that gives me 96 divided by 12, which is 8. Oops, this is plus or minus. So we get the same answer, but it's definitely a lot more work and more difficult calculations, right? So if possible, can you see anything, if you were to tell your friend how we know when we can use this method, what would you say? Like, how do you know whether you should factor or use a quadratic formula or use this method? This is just by taking the square roots. Good. When there's no b, very good. Because if I had x squared plus 12x equals 64, I can't use this method. I can't take the square roots because of the b that's there. Okay? So if there's a b, we're either using the quadratic formula or we are factoring. Oops. Either one will give me the correct answer, okay? If there's no b, then we're going to just take the square root of both sides. So here's another example. 9x squared plus 6 equals 105. I don't know. You tell me. Which one's going to be easier? Quadratic formula? Everybody agree? Why not, Caroline? There's no b. So the b is 0.
Definitely will be zero.
Wait, isn't that 60?
No, it's
Yeah,
not.
okay.
That's C, Rav.
So
Oh.
the b always has an x next to it. Okay? So what would I do?
You'll do the -6.
Yes, -6. Good. So we have 9x squared equals 99.
And then divide by 1.
Good. Divide by 9. X squared equals 11.
Just plus or minus.
Good. Plus or minus the square root of 11. Questions? Okay, I have a worksheet for you to practice with this, and then we're going to do some more stuff.
It's 6 and 7.
Okay. So number 6, we're going to subtract 10 from both sides, right? So we get 4x squared equals 81. And then we'll divide by 4. Okay. Leave it like that. 81 and 4 does not reduce. But if you notice, they're both perfect squares. So when I take the square root of both sides, I get x equals plus or minus the square root of 81 over 4. We okay with that so far? All right. Well, what's the square root of 81? 9. And what's the square root of 4? 2. There's your answer.
So we can get fractions.
Absolutely.
But not decimals.
And then will you do the percentage?
Correct. I don't want decimals.
Will you do the percentage?
You can do that one yourself.
It's 5 over 2.
Okay, so I'm going to show you the answers, and then we'll go over any questions that you might have. What do you think? Questions?
Um,
Okay, how about you give me a fist of 5 so I know how you feel about this? Solve taking the square roots. Excellent. Wow. Okay. Good. So we're going to spend the rest of the period.
can you go to the first?
Mm-hmm. Okay.
Go down. Oh, I don't understand. I got 3 for 7.
You got 3 for 7. Okay.
Square root of 3.
So tell me what you did.
I subtracted 1.
Okay, and that gave us 25, not 24.
I got
That's where you got your 3 from, right?
Yep.
Okay. Good. Easy mistake to make. Yes, other questions? Okay. So we are going to spend the rest of this period converting between the radical and the exponential form. Okay. So what do I mean by radical? What's a radical? What is it? What's a radical? It's interesting that you're stumped on that, because a lot of times I hear you, like, if you read that number to me, don't a lot of you say radical 3 when you read that number to me? Right? So this is a radical. A radical has some sort of root. Okay? This is a square root, right? It could be a 4th root. It could be a 5th root. Okay? A radical is something that has a root. So we've been working with radicals. What we're going to do now is learn how to put the radical into exponential form. We take our next math test, man, you guys are going to nail it. You're going to be like, yes, I know this now. Okay, this is actually really easy. So let's say that I have the square root. We'll leave it as the square root of 3. Okay. What's the assumed number outside this radical? 2. 2. It's assumed to be a 2. What's the assumed exponent of the 3 inside the radical? That has an exponent of 1. We assume it to be 1. Okay? In order to change this to exponential form, this is our base, 3, and we're going to write it to the power of 1/2. Okay, the square root of 3 can be written in exponential form as 3 to the 1/2. Okay, the rule, and I know I think a lot of times it's easier to see it with numbers before you actually see the general rule. This is how it looks, right? If we have x to the power of a, and then we have a power of b out here, then this is how we write it as an exponent. And I think that's confusing, but when you see it over here, it's not confusing. Okay? Basically, what we're doing, we're writing the radical as with an exponent in exponential form, and it's going to be a fraction. The exponent's going to be a fraction. The bottom number of the fraction comes from outside there. The inside number comes from there. So if I had the square of the, let's say the 5th root of x to the 3rd, I can write that in exponential form as x to the, right? This number outside, that goes on the bottom. And this number inside, that goes on the top. So to the 3/5. Okay.
Are we taking another math test this?
Yes, we will
Oh, we
be.
are?
Yep. I just decided to wait till the very end so that we could cover as much material as possible before you take it.
Are we taking 2 or 1?
One?
Oh.
You want to take 2 of them? I'm just wondering where the question comes from. What are you thinking?
I just thought, I didn't know if we would like take 2 or if we would take 3. Like I thought we had already.
We've actually already taken 3 of them.
Oh, we have?
Mm-hmm. Took one in August, we took one in December, and we took one in March. Okay, how about this one? How about the fourth root of 3. Can you write that in exponential form? Tori, what do you think? Okay, 4 over 1. Everybody agree? No? Yes, 1 over 4. Good. Remember, the number on the outside goes on the bottom. Okay. How about this one? No, let me change it. Let's just make it a 3 there. Okay. So we want to write this in exponential form. So what do we have to change?
We have to change where the 3 is. No, is it the
Let's change what's inside first. So how do we write that? 7 to the power of 1/2. Square roots are always 1/2, unless there's an exponent inside there. Okay, but plain old square roots are always 1/2. Okay, to the power of 3. Who remembers what do we do when we have an exponent outside the parenthesis? We multiply. We multiply. So we're going to do 1/2 times 3. What's 1/2 times 3? 3/2. 1/2 times 3 is 3/2. Notice we're leaving it as a fraction, right? We're not changing it to decimal.
How'd you get the 1/2?
Because there's an assumed 2 outside here and there's an assumed 1 right there.
Why is it 2?
Because it's a square root. All square roots have an assumed 2 outside there. Okay.
Wait, why do we have? Oh no.
How about the cube root of 5 squared to the third?
Dang.
It's scary looking. What do we do with that cube root of 5 squared inside? How do I change that? 5 to the 2/3. Good. The number inside, that goes on the top. The number outside, that goes on the bottom. And then we're to the third.
Wait, so why did we multiply it like the problem before, but not this?
Just because we haven't gotten there yet, that's all. We're going to multiply it now. Good question.
Isn't it to the 6/3 basically 2?
So we multiply 2/3 times 3, right? That's actually 3 over 1, right?
Yes.
So we multiply straight across. So this becomes 5 to the power of 6 over 3.
2.
And 6 over 3 is 2.
25.
And 5 squared is 25. Good. Notice in the one before, we left it as 7 to the 3/2 because it didn't simplify to a nice whole number.
So we want it to be a whole number if we can.
If it can, yeah.
Can-
Okay.
can.
And you can use your calculator to do the fraction stuff if you want to. Okay. Okay, how about this one? Um, Okay, so let's do what's inside the parenthesis first. What can we do with that?
Square.
It's 6. Square root of 36 is 6. Yeah. And then what? Square 6 and we get 36. Da-da-da-da-da. Which we knew anyway because we know that when we square a square root, it just gets rid of the square root. Yes.
So if I did it 36 to half.
Good question. So yeah, notice how it would work the same, right? If we did 36 to the 1/2 and then squared it, right? And then we know that 1/2 times 2 over 1 is 1. So we get 36 to the first, which is 36. Same thing. Okay. Question so far? How about the 4th root of 11 to the power of 2? Okay, we work inside the parenthesis first. So how do I write that 4th root of 11? 11 to the power of 1/4. Good. Everybody okay with that step?
Yeah.
And then what? Multiply them. Yes, so that becomes 11 to the 2/4, which is 1/2. Good. Excellent. Okay. Okay, what if we wanted to go the other direction? So we start off in exponential, like 5 to the 1/3, and I want to rewrite it as a radical. So we know that the 5 goes inside. Okay. The number on the bottom, where does that go? On the outside. And the number on the top goes inside. So that's it.
Now, do you have to put the 1 more?
No. Okay, so let's say that we had 7 to the 2/3. Let's rewrite this in radical form. Okay, so the 7 goes inside. The 3, where does that go? Outside. And the 2 goes right here. So there we are. Okay? Okay, I have another worksheet for you. You're going to start it now and then you'll finish it for homework. Okay?